Good evening students. In today's class we are going to discuss the numericals from current electricity. Before that I have mentioned the formula here. So charge Q, then current I is equal to Q by T, potential V W by Q. We are going to apply these formula in the numericals. So fourth one, according to Ohm's law, V is equal to IR, then conductance is 1 by resistance. So if you draw the slope of VI graph in some of the questions is delta V by delta I, which is equal to R. So next, resistance is equal to rho into L by A. So specific resistance rho is equal to, you can calculate by using R into A by L. So area of cross section A and L is length. So units are ohm into meter. Next, conductivity is nothing but 1 by resistivity. Accordingly, we will get the unit here. Now let us solve the numericals in 8A. So what is given in this first question? They have mentioned N, that is 6.25 into 10 to the power of 16. So 2 seconds time. So the charge is given as 1.6 into 10 to the power of minus 19 coulomb. And the question is find I, nothing but the current flowing through the conductor. So you know the formula, I is equal to number of electrons into charge divided by time. So substituting, we get 6.25 into 10 to the power of 16 into charge of each electron 1.6 into 10 to the power of minus 19 coulomb, and time is 2. Hope you have understood this. Upon calculating, we get I is equal to 5 into 10 to the power of minus 3 ampere. So nothing but 5 milliampere. So milli is 10 to the power of minus 3. So this is about question number 1. Second question. So here they have mentioned the current, right, and they are asking how many number of electrons are flowing through this conductor. So what is given here? The current I is equal to 3.2 milliampere, nothing but 10 to the power of minus 3 ampere. So the charge of electron 1.6 into 10 to the power of minus 19 coulomb. Now N value, that is how many number of electrons flow through the conductor. So apply the formula, I is equal to N into charge by time. So they have asked it in 1 second, so we can calculate it as, so I value, you know that 3.2 into 10 to the power of minus 3. Now N we should find out. Charge is 1.6 into 10 to the power of minus 19 divided by 1. So send this to other side. So N is equal to 3.2 into 10 to the power of minus 3 divided by 1.6 into 10 to the power of minus 19. So we get 2 into 10 to the power of 16 electrons will flow through the conductor. Hope you have understood this. Next. So question number 3, they are asking find the potential difference required to flow through the when you are flowing a current of 300 milliampere in the wire of resistance 20. So given I is equal to 300 milliampere, milli you can take it as 10 to the power of minus 3 ampere. Now resistance is 20 ohm. So we use Ohm's law, V is equal to IR. So we should find what is V. So 300 into 10 to the power of minus 3 into 20. So we get 6 volts. Hope you have understood the third question. Next. Question number 4. So they have given electric bulb is drawing 1.2 ampere current and voltage 6. Find the resistance they are asking. So what is given? I is equal to 1.2 ampere. Voltage is 6 volt. R you have to calculate. So substitute in the formula again. R is equal to V by I, nothing but 6 by 1.2. So you can have 5 ohm is the answer. Next, question number 5. So what is given here? So I, they have mentioned 2 amperes here. Voltage is 12 volts. You have to find out R. According to Ohm's law, we can take V by I. So 12 by 2, which is 6 ohms. Right. So, and they have also asked, will the resistance be more, same or less when the bulb is not glowing, right? So definitely the resistance is less if the bulb is not glowing, right? Also there is decrease in the temperature. So hope you have understood question number 5. Now in question number 6, first write down what is given. Resistance is given 5 ohm, voltage is 3 volts. Now they are asking calculate the current. So I is equal to, you can take V by R, which is equal to 3 by 5. So we get 0.6 ampere. So very simple. Question number 7. In this they have given the experimental verification of Ohm's law, and you need to draw VI curve and then answer this. So if you draw the VI curve, you get like this. So I on x-axis and V on y-axis you take. So you have to take it as voltage, we can write it as 0.5, 1, 1.5, 2, then you take 2.5. Here you can take 0.2, 0.4, 0.6, 0.8 and 1 in terms of volts you have taken. Now accordingly, if you draw this, first 0.5 is at 0.2, right? Then at 1 it is 0.4 here. Next 1.5 is 0.6, 2 we have at 0.8 and last one is at 1. So you get like this. Hope you have understood this. Now accordingly, first question is potential difference V when I is 0.5A. So I is equal to 0.5A. You want to find out what is V, right? So if you observe this, I value is 0.5, so you can take here, right? And then what is the voltage you are getting, you will get here. So this will be 1.25 ampere, 1.25 volt. Next, they have asked the current I when potential difference is 0.75 volt. So if V is 0.75, so at this point you bring it here, now it will be 0.3. So I is equal to 0.3 amperes, right? So hope you are able to understand this. Next they asked what is the resistance. So third question, R is equal to V by I. So you can take V value if it is 0.5. Now I value is around 0.2 they have mentioned. So any value you can take and you will get the answer. So this is 2.5 ohm. Hope you have understood the 7th question. Next 8th one. So first wire and the second wire. So what is given here? So they have mentioned R1 is equal to 1 mm and R2 is equal to 2 mm. So length, let us take L here. They have asked same length and also same material, radius alone is different. Now in the first question, they are asking here their resistance should be compared. So let us take, if you write R1 is equal to L by pi R1 square and R2 is equal to L by pi r2 square. So length is same, pi, you can cancel it out. Now if you take r1 by r2, you are going to get 1 by this pi also we have cancelled. So 1 by r1 square divided by 1 by r2 square. So you are going to get r2 square by r1 square. So substituting, you get 2 square is 4 and 1 square is 1. So answer is 4:1. Hope you have understood. Now second one, they are asking to find out the specific resistance. Because it is made up of same material, both the wires are made up of same material, so specific resistance will be same, so 1:1 you can take. Hope you have understood this. Next, question number 9. So what is given? They have given resistance is equal to 1 ohm and mentioned that it is stretched to double its length. Right. Imagine R1 is equal to rho into L1 by A1 and R2 is equal to rho into L2 by A2. Right. So we can take it as this, you cancel. So R1 by R2 will be is equal to length by, if you take length as L, this is A, divided by length is doubled, so 2L by half A. Right. So area of cross section is becoming half. So what will be your answer now? So on substitution, we can take it as R1 by R2 will now become 1 by 4. So therefore R2 is equal to 4 ohm. Hope you have understood this. Next, question number 10. So R1 you can take rho into L by A, right? R2 also rho into L by A. So first R1 is 3 is given, so rho into length is given as 10, area of cross section take it as A. So R2 is equal to rho into 30 by A now, right? So here, assuming it has uniform cross section, fine, stretched it to 30 centimeters. Okay, so length is being increased 30, that we have written. Now what is R1 by R2? So on substitution, if you take, so it will be 3 by R2, which is equal to, you can cancel this, right? And it will be, so 10 by 30, so nothing but 1 by 3. So therefore cross multiplying R2 will become, you will get 9 ohm. Hope you have understood the question. R2 is equal to 9 ohm. Now let us solve 11th question. So they have given R1 is 9, L1 is 30 centimeters and R2 we have to find out. L2 is given as 10 centimeter. So area of cross section becomes 3 times is given. So applying the formula, R1 will get the value of A, that is nothing but 10 by 3. Second one, substituting that in the formula, so R2 is equal to 10 length divided by 3A, A is equal to 10 by 3, so we cancel it out and finally you get R2 is equal to 1 ohm. Hope you have understood. Now let us see question number 12. So in 12 they have given what length of copper wire of specific resistance 1.7 into 10 power minus 8 ohm and radius 1 mm is required, so that its resistance will be 2 ohms, right? So specific resistance rho is given as 1.7 into 10 to the power of minus 8. Then radius is 1 mm, so we can take it as 10 to the power of minus 3 meters. Resistance is 2 ohm. Length we have to find out. So R is equal to rho into L by A. If we substitute, 2 is equal to 1.7 into 10 to the power of minus 8 into L by pi r square. So R value is given. So if you are checking out finally length on all the substitution, we will get 369.4 meters. So hope you have understood. You can substitute the values and calculate. Now the last question, 13. So what is given? They have mentioned I1 100 milliampere, V1 is equal to 0.2 volt, and I2 is given as 400 milliampere and V2 is 1 volt, right? Now they are asking what happens to the resistance with the increase in temperature. So R1 is equal to V1 by I1, which is equal to 0.2 by 100 into 10 to the power of minus 3. So here you are going to get 2 ohm. R2 you take V2 by I2, which is equal to 1 by 400 into 10 to the power of minus 3. So nothing but 2.5 ohms. So we can say that the resistance of the filament will increase with the increase in the temperature. So R increases if temperature is also increased. Hope you have understood this. These are the exercise numericals 1 to 13. Thank you so much.